Hello and welcome to the Bearded Kubernetes. My name is Leo. Glad to see you. Could you please set a plus sign to the chat for me to understand that sound is good and the picture is okay? Oh, fine, thank you. Okay, we'll talk about the Kubernetes architecture today, and we'll see some examples of how we can create a small and quick Kubernetes cluster using virtual machines. But first, we have to talk about the Kubernetes architecture. I think that you have seen a lot of presentations about it, but I'd like to follow some philosophy, some logic of building it. So maybe my presentation will be a little bit different from the others. So okay, so I'll start with the nodes. I mean, what is nodes? Nodes, in our understanding, is an isolated computing resource. It could be bare metal server, it could be virtual machine, or anything you can imagine of, but first thing to understand that there is no difference for Kubernetes, is it a bare metal or virtual machine. So what makes node a node? It has to have an agent which does mostly two things. First of all, the agent have to report node state, and the second thing, to run thing we want node to run. Yes. So for Kubernetes, the name of the agent is kubelet, and kubelet is the only component which is basically installed as a software, and other components usually come as Docker containers, but we'll talk about it in detail a little bit later. By the way, if you have any questions regarding the presentation, you can use chat. I'm looking at it, so I'll try to my best to answer your questions. Okay, so we have talked about the node becomes a node when we install an agent. So, and we must have our nodes not so equal as they could be. So we have to split our nodes into categories. So we have to run cluster components somewhere. I mean, we have to run something that is that's doing some management tasks for our cluster. So we divide our nodes in two categories. Master nodes, they run components of the cluster, and the worker nodes, they run only the workload. Main thing to know is that kubelet is running on all nodes in cluster. Okay. So some nodes are more equal than the other. And then we have to create some server for our kubelets to report. So kubelet has to report its state somewhere and receive some instructions what it should run. So we have to create a kube API server. Kube API server is the central component of the cluster, and it's the talking point to everyone. So kubelet should report node state and receive tasks to run. So we make kube API server, and there will be more components in the cluster, but all the components will talk only to API server. That's very important thing to understand, that the components, all the components of the cluster are talking to each other only through kube API server. And once again, kubelet has to report its state somewhere, so we get, okay, talk to kube API server and report what's happening to you, how much resources do you have, etc. I hope it's okay, it's everything understandable, so put some plus sign or smile for me to understand that everything goes well and the logic is completely understood here. You can just put a smile or something else. Okay, now we have one more component, and kube API server is talking to everyone in the cluster, but kube api server have to store its state somewhere. So we would like to introduce etcd, a special component which stores the state of the cluster, and the state of the cluster is created from what kube api server receives from different sources. So we have to meet etcd. etcd is a simple key value storage. Well, not as simple as it could be, but kube api server is de facto the interface to etcd, and etcd itself talks only to kube api server, and each component in cluster talks only to kube api server. That's important thing. Let's look at it again. So we have kubelets. They are reporting their state and receiving their tasks from kube api server. Itself, kube api server talks only to etcd and stores everything there. etcd is just a key value storage. It's very simple. It has a lot of abilities of clustering, but we'll talk about it a little bit later. Right now we have to understand that kube api server talks only to etcd. I mean when we are talking about the storing of the data of the cluster. So next component we introduce is a kube proxy, because usually clustering means a lot of networking, and kube proxy is a component which is installed on each cluster node, which controls the network of the node. And so kubelet talks to kube api server, gets tasks to run, but there is a lot of magic in the networking, and I hope we will talk about it in details in a week or so. So kube proxy also talks to kube api server and configures node network according to the guidance from there. Well, it's fine to understand that kube proxy is not the only component which affects networking. There are a lot of different components affecting networking, but kube proxy is definitely one of the important ones. So, okay, going further. And here we should meet a runtime. Well, runtime is a very specific thing, but before, maybe you've got some questions. I'll make a little pause. You can ask me. Okay, you can just put a smile or something else for me to understand that they can go further. But if you have any questions, please ask them. Okay, now we have to use kubelet to run something on a node, and we are talking about the container runtime. Well, when talking about the container runtime, we have to understand what is it. So everything is Kubernetes is run as containers. They have special name because they are not just containers, and they are called pods, and we will talk about them in more details later. But what is really important is that kubelet needs container runtime. What is a runtime? Well, for most of us, runtime means a Docker command, and we can ask Docker to run a container, download an image. But in fact, when we are using our Docker CLI client, it talks to this using the socket to the special daemon, Docker daemon. And Docker daemon has libraries with functions which allow him to download images, run containers, etc. But the most funny thing about the runtime lately was about the deprecation of the Docker as a runtime component. No, nothing to be afraid of. Docker is here with us for a long time, and it will stay, but there is a very funny picture about it. I can't hesitate to share it with you. Yes, about the Docker being itself using containerd. So in modern configuration, there is no Docker itself on a node. just container D as a special library which has all needed functions to run containers, download images, etc. So actually right now Docker is needed to build a container, but there is no need for Docker to be installed on a node to run containerized workloads, and it's very funny about it. So yes, and the notes about the deprecation of Docker is very funny, really. So we have a complete worker part. It has three main components. Yes, it's kubelet, it's kubeproxy, and container runtime. So it's the worker part, and each cluster node has worker part. But there is two more components for the cluster to be complete. So let's talk about them. First is a kube controller manager, and it's a really complicated component when you're looking at it for the first time, and we'll try to discuss it in detail. So kube controller manager, it talks to kube API server, and it contains the thing which is called controllers. What is a controller? Controller is an isolated thread of code with reconciliation loop. And reconciliation loop is the most important thing for cluster. So what does reconciliation loop do? First of all, it has to read the desired state of the cluster from kube API server. Second, it should read the current state of cluster from kube API server. And step number 3, write to kube API server actions to get from the current state to the desired state. When looking at it, it's rather easy and not very complicated task, but there are a lot of controllers, and each component of the cluster, each object you have to create in cluster has a corresponding controller which does what he needs to do to make cluster to the desired state. And actually, when looking at this picture, you can ask, so it's where are these states came from? So desired state, current state, how can we understand what's going on in the cluster? So actually, once again, reconciliation loop is an endless loop, and it compares desired and current state. So desired state is provided by the user of the cluster. So user says, please run X containers with Docker image of Y. And the current status is provided by the kubelet. Kubelet says, okay, this is kubelet on node 8. I have the following containers and their statuses. And kubelet reports continuously. So reconciliation loops of controllers can compare desired state, current state, and understand what they need to do. Run more containers, shut down container, or do something like that. And actually, the cluster itself is based on the reconciliation loop. So, cluster state means a lot, but basically, when we are talking about the state of cluster means, first of all, the status of the pods. So, for example, user does provide the desired state. So it says, I would like to have 5 containers running. So kubelet provides information about which container is running and which is not, and a reconciliation loop inside the cluster decides which containers we should run. So for example, if we had some kind of error or problem with container, it has failed completely and crashed. So the reconciliation loop sees the state of the container as terminated and schedules one more container to be run. So it's that reconciliation loop, and the current state usually means the number of pods number of containers currently running. And the second main important part is the resources of the nodes in the cluster. For example, if there is no notification from kubelet of node running, cluster considers it failed and tries to schedule other pods to other nodes. So it's very important to understand that kubelet reports the state of the containers it has, and also reports the availability of the node. So the cluster itself understands that node is here and node is working. Without kubelet, we won't be able to do so. I hope it's okay. I hope I've answered your question. Okay. So, and the last component we have to talk about, I mean, not the last one, because we have a lot of them really, is kubescheduler. And kubescheduler itself is a very important component because it makes a very hard decision about the status of the pods, of assigning pods to the nodes. So kubescheduler, we can just push the containers to kubelets. We should do some magic to keep our nodes equally busy. So, and the containers themselves could have some requirements. For example, I need a GPU to run, please, or I would like to have 3 copies of this container and ensure they do not coexist on the same node. Or I need 4 gigabytes of RAM to run, please. So there are different consideration when talking about the scheduling of the pods to nodes. So kubescheduler decides where it should schedule a container to. So it reads the requirements from definition of the containers. So when you are defining the container to run, you can set the requirements there. I mean, requirements is how much of CPU time you would like to have, how much of memory you would like to have. On the other side, kubelet reports the states and resources of each node. So kubelet reports, okay, I am node A, I have 16 gigabytes of RAM at 4 processors, and I have 8 gigabytes of free memory, for example, and my average load is X, etc. So, and kubescheduler takes into account all the limitation and requirements and decides one simple thing: which node in cluster should run the container, the exact container we have to schedule, we have to run it. And it's a very complicated process, because when we are talking about our scheme where we have only one worker node, the scheduling is that easy, so you have only one worker node. But when you have a lot of worker nodes with different considerations about memory, CPU usage, it's a really interesting task how to schedule pods to nodes to have them equally busy. So once again, about the components, it's rather simple, but I think it's still maybe not very good understood. Each node in cluster runs kubelet, kubeproxy, and container runtime. Each master node has a little bit more. It has an kube IP server, etcd, controller manager, and the scheduler. So these are the components of any cluster, and actually there is a lot of things to consider when talking about why there are so many components. And actually, when talking about it, it's a very interesting question. So I think, and it's my own opinion, that Kubernetes follows Unix philosophy. Do one thing, do it right. And you can compare it, for example, to HashiCorp Nomad. It has just one binary with all the components inside. So either way has its own pros and cons, of course, and there is no silver bullet here. But for me, Kubernetes really tries to follow Unix philosophy, and it's awesome. It's okay. Maybe it has a lot of moving parts, and maybe it's harder to understand, first of all, but when debugging Kubernetes, it's easy to have a lot of small components doing the job than to have one giant component and with problems inside it. So for me, this is it's okay. It's Unix philosophy. And one more thing, looks like we still miss one thing: a user. So how can one control the cluster? Well, there is a client application for that. It's called kubectl, and good to know, it just sends good old HTTP requests with REST inside. And of course, as you can think, that the kubectl talks to kube API server. So when we would like to see it in detail, it's like this. So we have our master nodes, our worker nodes, and our user with kubectl, and it can talk to API server to know the states of objects and to control it to create new objects in the cluster. Okay. Now there is a small thing to notice, but actually usual setup of cluster uses self-signed HTTPS certificates, and for some reason KubeADM, its widely used cluster initialization tool, usually creates certificate for Kube API server with a 1-year lifespan. And sometimes it comes as an unpleasant surprise because 1 year is a rather small period of time, and if you have your cluster failed exactly in 1 year, just ensure the certificates are right, because there is the biggest problem with the self-hosted clusters, knowing that KubeADM generates certificate with 1 year lifespan. Yes. Okay, so still to discuss, we have to understand one thing, that Kube API server seems to be the lovely and the single point of failure. And there is an interesting point: how can we make more master nodes and what complexity does it bring? Because actually when you have one master, it's very simple setup, but it has a single point of failure, and we are building cluster to not to have a single point of failure. Yep. So we have to create more masters and understand which complexity it brings, because there is an interesting things. So when we're looking at the cluster in the detail, we will understand that it's not about Kube API server. Anyway, API server is just a proxy between etcd and other components. And when we look at the scale, we should scale out etcd, and the good news, it's good at scaling. So we can easily have multiple etcd nodes. But what's underneath etcd? So how can we have multiple etcd nodes? Well, they have a special Raft algorithm. And what do we know about Raft? Well, not much yet, but it definitely recommends to have an odd number of etcd nodes. Why odd? Well, it looks like it's the best way to achieve quorum and protect etcd cluster from a split brain condition. Really interesting thing that a split brain condition, of course, is a great problem for clusters, and the odd number of nodes makes it easier to achieve quorum. So actually, let's try to talk about Raft, just a couple of words. So first of all nodes should have a low latency connection, and for Raft protocol, the latency between Raft nodes will be the killer. So Raft nodes do select a leader, and leader does all write operation and distribute new version to the other nodes. And Raft nodes do reselect a leader often. And the good thing about it, if you try to write data to a non-leader node, it just submits right to the master and wait for a distribution back. So actually it's very simple scheme where you can write to any etcd node, but if it's master, you have a faster write, but you have to wait for the distribution. If you are not master, then have to write and then to wait for a distribution. So the main thing to consider is that we should have a low latency connection between Raft nodes, between etcd, and this is a problem when you are trying to build a multi-regional cluster, because between availability zones in cloud providers you can have a small a low latency, but when talking about the multi-regional clusters, actually the latency of 100 milliseconds will affect you very much. So that's the problem, and that's the reason we still don't have a good solution to build a multi-regional cluster. Okay. So rethinking multiple masters in a cluster is a perfect solution, and you can talk to any kubeAPI server you want. If it has a etcd leader, you write to it. If not, etcd will send your write to leader. So it's that simple, and it's working really good. So this is the scheme of high availability cluster with multiple master nodes. And I'll highlight in yellow the components which are currently working, because really we don't need multiple kube schedulers or multiple kube controller managers running inside cluster. But etcd is always running and API server is always running, so we can get a simple load balancer in front of kubeAPI servers, and nodes can talk to it and forward the traffic to API server and then to etcd. So this is a typical setup of highly available Kubernetes cluster, and once again we have to achieve a low latency connection between etcd. So we have to build a low latency connection between our master nodes, and that's once again the problem of building multi-regional big clusters. So and what about those two? I mean about multiple kube schedulers and multiple kube controller managers. So how do they coexist? Well, they don't have the feature-rich protocol that ATC does. I mean, they don't have a Raft protocol to select or reselect leader, and they have a simple blocking method of selecting who is the leader. And actually, they just select one master, and the other replicas are doing nothing. If a node with master kube scheduler, for example, goes down, the other replica steps in. There is nothing to lose here, because scheduler or controller manager operates on the data they receive from etcd. So they do not store the state themselves. Everything is stored, all the state of the cluster is stored by etcd. So there is no problem if node with currently working kube scheduler goes down or the node with controller manager goes down. It's okay. So basically, once again, here is the highly available setup. Yes, once again, we have only one controller manager, only one kube scheduler running, and we also have kubeAPI server and etcd. Okay. And how components are run. This is very interesting part, because actually Kubernetes does run its components inside. I mean that the only component running as a usual process is kubelet, and in most cases everything else is run as Docker container, but a special one. And actually we usually have to install only the kubelet. Is this the end of the architecture? Well, in fact, no. There is still two components which make our cluster complete. We'll have a look at them a little bit later in the second part. But first is a network plugin. For each node in cluster should run it. And the network plugin managed container networking between nodes. And the second thing to consider is a DNS resolver of multiple replicas of it over the cluster. Cluster had a service discovery, so it's done via custom resolving daemon. In recent version of Kubernetes, it's core DNS. So actually, these two components, they aren't the part of the Kubernetes architecture itself, but they play a very important role in the cluster running. So we'll look at them a little bit later. So now we've almost reached of the end of the first part. Do you have any questions? If it's okay, let's take a 5 minutes break and get back to it. Okay, let's have a small break. Be back in 5 minutes. Okay. Yep, good one. Okay, let's continue and let's talk about the how do I create a cluster. It's a very important and interesting question, and we'll be seeing some demos here. I hope you will be following along. Okay, so first of all, we have to talk about the special ability of a kubelet, which has a feature called static pods. We still didn't discuss pods, but you can think of them as a containers at the moment. But why is it important, and what is a static pod? Static pods are the pods which are defined by the YAML manifests of files in local directory. So for kubelet, it's the direct command, run these pods and ensure they are always running. And kubelet creates them as it sees the files and recreates them when the files change. And kubelet mirrors these nodes to a kube API server. We can see them in the pod list, but we cannot control them. It's a very interesting thing because, well, actually the static pods are the main important building part of the Kubernetes, because actually bootstrapping a cluster is about running some static pods with etcd and API server. But we'll talk about these in details. So, how can we think about the cluster bootstrap at a glance? Well, first of all, we have to install kubelet to a node, then generate the resources we need, certificates for TLS, then generate manifest for static pods, because settings are usually given as command line parameters, and actually wait for kubelet to create them, and that's it, and we're done. Well, it looks very simple, but in reality it has a lot of complicated things, so we'll try to cover them here. So, and actually you don't create static pods by hands or don't generate the certificates by hands, and there are tools which are helping you to do it, and there is a different tools and different approaches. So a little bit more, we have two components we have to consider. So first of all, not all components, not all components at the cluster are installed as a static pods. We have two components more required for each cluster, and they are installed as an add-ons. It's a kube proxy on each node, remember, to manage the network, and the core DNS and master nodes to handle service discovery. And these components are installed as add-ons, meaning they are not just pods. They have a special requirements. For example, kube proxy should be started on each node of the cluster, and there is a special object inside the Kubernetes which ensures the defined container will run on each node of the cluster. And the second thing is a core DNS, because core DNS should not be run as a single pod, it has to have multiple replicas. So actually core DNS and kube proxy are not just pods, but as a result they are created by special objects inside the Kubernetes. And when we are talking about the add-ons for Kubernetes, it's completely fine to think about them as an application in the Kubernetes cluster. So I mean that basically a lot of components of Kubernetes are run as a containers inside the Kubernetes, and it's okay. For example, a dashboard or something else, something like that, it's okay. And network add-ons, well, it's the most complicated topic about Kubernetes. As for me, there is a lot of questions considering it, and we have to set up networking for a cluster, and there is a lot of options here. It could be Flannel or Calico or Weave or etc. There is a lot of network add-ons. And networking add-on is an application in cluster with a special functions. Which functions? Well, actually, networking add-on runs alongside with the kube proxy on each node of the cluster and helps to manage routing, IP addresses, etc. So when I was saying that it's not only kube proxy affecting the nodes network, Yes, the second component which affects Node's network is network add-on, and it does something with our networking. So, okay, let's talk about the tools. If you have tried some tools to create Kubernetes cluster, please put them to the chat. I'm interested. What tools have you used for it, and what were the results? And we'll talk about the tools. So, first of all, important notes: there is no right way, there is no silver bullet, and no the only way to make it work. I must say that everything here is exclusively my own opinion, and you can always use managed Kubernetes from cloud providers, of course, and not to do a cluster bootstrapping yourself, never ever. But actually, if you are looking into knowing Kubernetes, creating your own cluster is a must-have detail. And a lot of tools for Kubernetes cluster bootstrap, most all of them are based around the Kubernetes tool, and I would mention these ones: free, kubespray, kops, and Kubernetes itself. Actually, let's talk about kubespray. It's very popular for bootstrapping the Kubernetes cluster. It's completely Ansible, a lot of Ansible. And if you still don't know what Ansible is, it's a configuration management system, and the kubespray is the tool which help us to create cluster using Ansible. Actually, it's not so rock solid as it looks like. So when you are looking first time at the kubespray, you may think that, oh my god, there is a lot of Ansible code, there should be rock solid, it's been here for a long time. But no, nothing like this. And kubespray is good. It can manage updates for you, so I mean can help you to update the cluster version. And actually kubespray works well with bare metal installations, so if you are going to have a bare metal installation and you still don't know what to take, you can take kubespray, but you have to know Ansible. Second is kops. I didn't use it myself, but my colleagues did. So kops is a little bit less popular. It's just a Go binary. It can manage updates. Yes, it can bootstrap a cluster and manage updates for you. And kops is targeting to the cloud infrastructure. So kops is best when you have a virtual machine, so bare metal servers somewhere in the cloud, and you can use kops to create a cluster there. Once again, I didn't use it by myself. I can only judge on the comments of my colleagues. And the third one is Kubernetes. It's pretty simple. It's just a Go binary. It works well with bare metal, and upgrades are performed manually. So Kubernetes is a great tool, but it has a lot of complicating things with it. But if you would like to know Kubernetes better, I must consider for you for using Kubernetes first times, and I have special tooling to help us doing it today. So meet one more tool, K1S. So Kubernetes is great for cluster bootstrap, but you have to install it. Also, we need to do some operating system specific housekeeping, like installing packages, holding their versions, etc. So I've made such scripts for Ubuntu and open sourced them as K1S. I teach Kubernetes a lot, so just a second. I'll put a link to the chart. Here it is. And I teach Kubernetes a lot, so I need tools to start cluster fast show something. So let's take a look at it and try to create our first cluster. So it's demo time. Just a second. I'll share my terminal window. Okay. I hope you see the window well. Okay, so let's try to do something funny here. Just a second. I will add one more window. Yep. I will be showing it from time to time. Okay. So first of all, let's create a simple virtual machine. If you are following along, if you have the tools we need, you can just copy the comments from the presentation. So I will make a simple directory and create a small vagrant file from the content from Sponge us. It's just a small vagrant file. So I'll do it like this. Let me show you the... you can take the link from the second presentation. Links are below and below the video. So, and I will take my scripts from the Sponge. It's a very simple vagrant file. It looks like this. It's very simple configuration. I mean that there is nothing very specific here. Just a small virtual machine, which I have 2 CPUs and 2 gigabytes of memory. And afterwards, I can say vagrant up and spin the virtual machine. If you are following along, it takes a little bit of time to spin up a virtual machine. I don't have the... Oh! Still didn't delete it, obviously. Just a second. Yep. Delete all files. Let's try it once again. And so I have my virtual machine running. I can say background status to take a look at it. So it's definitely running. And once again, it's very simple vagrant file I use. So the only interesting thing that I would like to have a private network with this machine, with this virtual machine. And I would like it to be reachable from my host machine by this IP address. And then I configure the memory, name, and CPUs here. So it's very simple. If it's okay and you are following with me, you can put a plus sign and we can go on. So right now is just a small virtual machine I've created. I think it's completely understandable. What I need to do next, I would like to use K1S. Once again, it's a tool above the Kubernetes to run and create cluster. So I will use SSH to go to my virtual machine and then git clone the repo and then just install the components. It's very easy, 3 simple steps. First of all, use Vagrant to have an SSH, then clone the git repo and then go to the repo and run install script. It's very simple. Let's try to do it. So, okay. Yep, I'm here right now, so I can say git, and it's here, git clone. Yeah. Right here. So, now I have K1S, and I can go to its directory and say, okay, let's make install. Well, the script itself, it's not very complicated. You can take a look at it at the GitHub repository. Right now it installs the components needed to run Kubernetes cluster. There is not a lot of the packages. Yep, we can take a look at the install script. Well, the most interesting parts here are as well. So first of all, we install Docker, some components for it to add a new key for repositories, then the update repositories, install Kubelet, Kubernetes, and Kubernetes CNI, hold these packages to ensure they won't upgrade, turn off swap, and then a little bit do a small config tweaks with the Docker daemon, and then restart Docker and enable it. It's quite simple, so nothing very complicated here, and we just install some packages, simple step. Okay. And now the most funny part. We have to create a cluster, and there are simple commands, meaning you have to initialize it and you have to point to the network adapter, which will be the adapter where the API server will listen. So it's important, and we will have it like this. First of all, I'll say just init. It will show me interfaces, and I would like to use this one. If I would say API A, that's the adapter which holds my host-only network. So I would say okay. This takes a little bit of time because it has to download the images with Kubernetes, images with controller and proxy, etc. It will comment on what's going on. So right now it's running pre-flight checks. Pre-flight checks were a little bit sloppy because I've patched them. And then right now it's generating certificates, yes, creating the static pods, and now it's waiting for our pods to be created. So right now we are in a very specific situation because cluster initialization is complete. How can I say? I can say sudo docker ps and see that there is a lot of containers with the k8s prefix. It's Kubernetes, but itself cluster is not yet complete, because if I would say kubectl get nodes into namespace kube system, you can see that I have one node and it's not ready yet. And I can see some pods, they are not created and still pending. So core DNS is pending. And why? Because we still don't have a network plugin. And without network plugin, core DNS can't be run because it don't know how to get an IP address. And I have to install a networking plugin. So networking plugins are installed as manifests to cluster, and actually right now kubectl is configured, so I can say it this way: kubectl apply -f network, and I'll choose flannel. And the flannel is installed, and after that I can see pods initializing. It's flannel, and after that pods of core DNS will be running. So right now they are still pending because missing an IP address, and now they are running. So right now my cluster is completely perfectly running and ready. So let's look once again what have we done. So we've just run init command, and then afterwards we have to apply manifests for the networking. And I hope you are following along. I think that it's completely understandable, not very complicated. So now we can use our cluster to deploy a very simple application, and we'll do it in a second. I hope you are following along. So let's install a small application, okay, and we can issue some comments. So let's look. First of all, we'll create a namespace. It's like a separate directory for objects of our application. Then we'll change our kubectl config to change a namespace from default to namespace hello, and we'll run a deployment. What is a deployment? Deployment is a special mechanism to run. Yeah, great. Deployment is a special mechanism to run a specific number of pods. We can talk it and discuss it in details later. So let's try to create and deploy our first application to cluster. So I will turn my console back. Okay, so first of all, kubectl create ns hello. It says it's created. Let's take a look. Oh, really? It's here. Okay. Next step is to kubectl config set context current space hello. Yep. And now if I issue kubectl get pods, I get pods from hello namespace. Okay. And then I can create deployment. kubectl create deployment. We'll name it hello. We'll ask to run image from the custom Google repository. You can just copy paste the comment. I can type it. And if I issue kubectl get pods, I'll see container creating. It's rather simple, very useful. So it's running, and actually we have just run container with code of eco server. Still we don't understand all the details, but we would like to have an external traffic to it, so let's try to do it. I hope you are following along and your pod with the hello is running. You can put a plus sign for me to know. Okay, let's move on. And now I would like to have an external traffic. So I know that eco server is running right now as a pod in my cluster, but I would like to have an external traffic to it. I would like to curl it to see if it responds. So I can get pods with their IP addresses. Mind, I'm using a special options white to see the IP address of the pods, and I can do it like this. Okay, let's just kubectl get pods -o wide. So here we go. I can see the IP address of my pod, and actually right now I can curl it. So I can say curl and I see it's responding. But right now my pod is could be accessed only from the node which running it. So, but I would like to have an external access. How can I do it? Well, actually, the most simple thing to do is open some random node port to manage external traffic. It's not the production best way, but for our demonstration it will be completely okay. So I say kubectl expose deployment named hello and expose it using node port, and the port of the container is 8080. It says service hello exposed. Actually, it has created a special object which is named service, and now it was exposed using a special NOT port. I hope you are following along. George, is something wrong or not working? Share with us, please. Okay, how can I check that the kubectl expose did something what I wanted? I can just ask next question. kubectl get services and will show me very interesting thing. And when I issued kubectl expose command, it created special object named service, and you can see that the number of the port it's opened is here. So now I can use a port number to curl it from the local machine, not from the virtual machine itself. So I will open a new terminal window and do it like this. I can say curl and I see the response. So this is a very simple you are talking about all the pods in cluster. Yes, I will show you it in details. Yes, because actually nodes which I mean pods in cluster which are done for a system specific task, they do exist in other namespace. So kubectl get an s. As you can see, there is a namespace called kubesystem. Oh my! kubectl get pods namespace kubesystem, and here we go. So we have changed the default namespace in our config file to see only the pods or objects from the namespace hello. Yes, and if you would like to see the other namespace, you can just use -n to highlight the namespace you would like to see the nodes or pods or resources from. Yes. Yeah, so basically it was by issuing the comment where we changed the context and set it to hello. Okay, I've got nothing more to show, but if you have some kind of question you can ask, I would like to answer. Yes, and after all of these experiments, we can issue vagrant destroy to destroy our precious small cluster based in one virtual machine. But there is one more thing I would like to show you, that in the repository of the K1S there is a directory Vagrant, and inside it you can see two directories, single and twin, and these are the Vagrant files which are done to make the provisioning a little bit easier. So I can do it like this. Just a second. So right now I'll say suspend and show you what we can do from the K1S repo. You remember us doing all these commands: install, init, and etc. Boring, boring, boring. So I can use K1S for a simple task. This thing I'm doing right now from my own host machine, so I can go to Vagrant single directory, and we can spin up a fully functional one node cluster, just issuing Vagrant up. And it will do all the things it needs to do to create a cluster, and afterwards easily export configuration to use it. So you just check out K1S repo, go to directory Vagrant single and say Vagrant up, and that's it. You're good to go. Yes, and as you can see, it started provisioning itself, so you don't have to do anything. Just type Vagrant up, running cluster, in a couple of minutes. Yes, as you can see, it started initializing the cluster, and in a couple of minutes it will be complete Kubernetes cluster created by one command, Vagrant up. I like it. Once again, time for questions. Yes, and it's complete. So I just have to use the Vagrant to copy kubeconfig file. Be careful with it, because it will overwrite your existing .kubeconfig file if you have done it for some kind of specific cluster configuration while playing around. But I don't have anything important there, so I will just... Oh. I don't remember if I have kubectl. Yes. And now I can see the pods of my newly created clusters. Oh, George, I'm not very good with GUI tools. I mean, yes, for managing, but actually, well, I don't know. I feel in myself best with the combinations of kubectl, and that's all. So I really don't know. Actually, for the management, I've seen an interesting tool. Just a second. K9S. Just a second. Yeah, it's like just a second. I'll post it. Yes, this one. It's a command line interface tool, meaning that it's still like GUI, but can be run from terminal. That's funny. Yes, but I haven't seen GUI tools for deployment. I mean that looks like Rancher has some web interface for it, but not really. I don't know, not being a fan of the graphical interface in this area. Okay, if your cluster is working, then thanks for joining me today. I'm very glad, and so hope you are too. I think I will do one more demo with the networking of Kubernetes Unleashed, because it's a very interesting topic. So I think I will post announcement about it on the Kubernetes subreddit. Also in a DevOps subreddit. So hope you guys like it. You can share the video, share the tools, share the presentations. There's actually even a donation button there if you would like. Okay, hope to see you in 1 week. Bye bye.